We are doing problem 4A1. In this problem, you have a cart with velocity 1 going to velocity 2, which is equal to 0, over a distance s. We are given mass equals 2,000 kilograms. V1 at the start is equal to 80 meters per second. The friction force in the direction opposite of movement is 10,000 newtons, and we are meant to find the distance s and the time it takes to get from velocity 1 to 0 velocity. In step 1, we find the free body diagram and we do all the forces. So in the upward direction, we have force normal. In the opposite direction of the movement, we have force of friction. And down, we have the weight force. And then in step 2, we go over the coordinate system of I in the x direction and j in the y direction. In step 3, we go through our forces. Our force of friction is equal to FFI. Our weight force is mass times gravity in the j direction. And our force normal is the normal force in the j direction. In step 5, weight and normal force cancel out each other, so all other forces will be in the I direction. And then step 4, acceleration is equal to the acceleration in the I direction.
In step 5, we're gonna put all these steps together and put our force equals mass times acceleration equation. So we already said that the weight and the normal force will cancel out, those goes to 0. So then we're left with negative FF is equal to mass times acceleration. This is scalar. This is also scalar. Notice I made this force friction negative. That's because it is in the opposite direction of the velocity of the cart. So now what we're going to do is we know this is mass, this is acceleration. Acceleration is equal to the derivative of velocity with respect to time. So if we make this equal, we can also say, as a secondary equation, that if we want to find the distance, we can also say that A is equal to the derivative of the velocity over a distance times the derivative of distance with respect to time. So we're going to take this 2 directions. We'll start with this one. Start out with time t. So to do that, we're just going to multiply dt over. And so we're going to take the integral of both sides. This from time 1 over time 0 time t. And this one from v1 to v2. Then we're left with negative friction force times t is equal to mass times velocity 1, that's supposed to be 2. And this is going to be 0, so it'll cancel out. So then you're left with P is equal to mass for velocity 1 divided by friction force, which is equal to 16 seconds. And when we're talking about distance, dv ds over ds dt. So then we know that, we'll go over here. Can you see that? Yep. Yeah, you can. Negative friction force is equal to mass dv ds over ds dt. We know that this term right here is equal to velocity. So you have negative friction force equals mass times velocity dv ds multiply ds over friction force times ds equals mass times velocity times dv. Integrate. 2 is equal to 0. And you have time 1, position 0, 2s, left with negative force friction times s equals mass times velocity 1 squared divided by 2 to take the integral. So then s is equal to 640 meters.
Now, some of you may be asking, where is the force that goes this direction? In this specific problem, we are only given a velocity at the start. There's no force moving this cart from the beginning. This cart is only powered by momentum, which is why there's only the friction force and no force being applied.